Hi, I'm Asaf. I'm one of the co-founders and the CEO of Granulate. I'll be presenting Granulate as an intro to everyone listening, and thank you for having us. So, as you can see on screen, Granulate is a real-time continuous optimization solution. Basically, we want to help companies handle their workloads with anywhere between 20 and all the way up to 80% performance improvements. Our emphasis is on the performance improvements, but a lot of our customers choose to take that into cost reduction. You can see on the screen some of the numbers that we've been getting with our customers. You can also see them on our customer success stories on the website. But I think one of the most important parts is the no-code changes. So the premise behind Granulate is that everyone in production is using Linux operating system, or at least most. And Linux was built with a user behind the keyboard in mind, so for interactivity and fairness, which means that we are trying to make everything run very smoothly, no matter what the user does. But in production systems, we have a unique set of circumstances that allows us to improve on top of that. One is the fact that we're running the same processes over and over again, granted with some different data, but in fact, the data flow itself is very repetitive. And the second part is we have a different optimization function. This could be response time, latency, throughput, IOPS, whatnot. And if we align the decision-making within the Linux operating system and kernel to our optimization function, we can reach those performance improvements. Let me give you a quick example based on microservice as to why it's so important. Let's assume that we are running on a single server on service A right here. And what happened is an API request would come in. Let's assume that it's a user that logs in, and that user has to be verified, and then we want to query some history, we want to give them some new insights, some new recommendations, whatnot. So a lot of it will be independent. Some will be serial and some will run in parallel. So we'll send it in parallel to multiple services, and then maybe a few of them will return a response before others. Now, from the operating system perspective, we have data that we need to process. And so we'll address that, and we'll have to address that as fast as we can because we want to run very smoothly. But from the application standpoint, this is not necessarily the most important thing to do. If this was the only thing that we had to do, that's fine. But since we're probably processing anywhere between tens of thousands of requests at the same second, this could be that we can't return a response for this particular request, while there may be other requests for other users, for example, that all of the data has been returned and we can return a response back to the user, but we're simply waiting on this data to be processed. Another example is if a request just came in and needs to be sent to all of these, but once again, it's waiting for data to be processed for a request that no matter how fast we process that, we're still going to be waiting on services Y and Z before we can return a response back to the user. And so this is what Granulate can eliminate. We can align the user's optimization function, which in this case would be latency, because we want to return a response back to the user as fast as possible, with the decision-making within the Linux operating system and kernel in order to understand which, in this case, data to process first in order to avoid that waiting time. Now, why organizations don't do that today? Well, first of all, there's no API to tell the kernel on a thread level within the same process how to prioritize. There's only the ability to do that within different processes, but the kernel was built for interactivity and fairness, so it's pretty good at distinguishing between those. And if you don't have that ability, and you try to run at a very high utilization, so a tight amount of resources, you end up with a lot of performance degradation and latency spikes. In order to avoid those, and to avoid that contention, organizations resort to what they can do today, which is increasing the amount of resources and run at very low utilization. Unfortunately, this is how they lose twice, because they're not only paying for what they provision, they don't get the best performance. And this is exactly what Granulate is here to solve. Granulate is given by the user that optimization function, latency, throughput, IOPS, whatnot. And then it would hook into all the contentable resources, CPU, network, mutexes, memory accesses, disk accesses, and so on. It would optimize and prioritize the decision-making as to which resource to allocate to what task at any given moment in time. And then we can get those better performance. And if we want to, we can reduce costs simply because we can do more with less. Thank you.
Why do you think there's so much untapped value to be had from upgrading existing financial institutions' tech infrastructure?
From what we are seeing with our customers, you can gain anywhere between 40 to 60% compute cost reduction, which also translates to energy consumption and carbon footprint reduction with most of our customers on average. And when I think about the infrastructure that FIs have today, I see a huge amount of potential there as well. Where in the past you couldn't prioritize between different tasks of the same process like we're doing today, Granulate introduced that, and already with existing customers, whether they're born to the cloud or on-prem, we're seeing those huge results. And I'm super excited about the amount of infrastructure that you can either reduce completely or simply move to other areas and innovate on top of that infrastructure. Instead of having to take care of the amount of resources that you have, you can focus on innovation. This is why we're so excited about the space, and this is why we're so excited to get to work with the financial sector.